Continuation on exponentials. Today we're going to talk about specifically exponential growth and decay here in Chapter 5, Section 2. Exponential growth and decay, which we spent a fair amount of time discussing on the first video of this unit. And we'll just get into some more specifics with that today. One thing that we did not really talk about in the last unit is if things are growing, they don't always grow nicely in weekly increments or yearly increments. Sometimes they happen in minutes, half days, months instead of full years. So you do run into some things that the exponents are not really as nice of numbers as you would like. We call them rational exponents as opposed to last section when we dealt with strictly integral exponents, which are the integers, the positive and negative whole numbers. So a couple definitions we need to start with here. B to the 1/2 power, what is that equal to? Well, if we think about that, we can kind of derive what that's equal to, because we know that the property of exponents, if I have something half power and then I square it, I multiply my exponents, and I get b to the first power. So what that tells me is squaring undoes a half power. Undoes, I don't know if that's really a word or not. Squaring undoes a 1/2 power. Well, we all know that square roots undo squaring, so this is really the same thing as the square root of b. Okay, so if you see what happens here, we write a little 2 in the index for square roots. We typically don't show that because that's the typical square root. The 2 is built in. Okay, where we do show that though is if we have 1/3, the 3 is our index, and we get a b inside there. If I have 2/3, now we're getting tricky. This is fancy stuff here. Well, that's b squared, the cubed root of b squared. And if you think about it, that should make sense because that is b to the 1/3, and that is being squared, and b to the 1/3 is the cubed root of b, and that is being squared. So there we go. Okay, those are equivalent expressions no matter how you write it. If you want to write it like this, or if you want to square it first, it makes no difference there. Okay, so those are equivalent expressions. In a nutshell, that is our powers with rational exponents. So if you would like a general form, let's call it b to the a over n. That'll be the nth root of b to the a, or it'd be the nth root of b to the a. Okay, again, equivalent expressions. The numerator is the power, the denominator is the index, and b is always your base. So let's put that into perspective here and see how that has any relevance at all with what we're doing. And notice I still have this little disappearing act going on here. So let me go forward and jump backwards, and it's magic there. Mr. Nice the Magician brings it back. All right, so let's take an example of a car, and a car we know loses value over time. So a car depreciates by 20% a year, let's say. So we don't know if that's a Ford, a Chevy, an Audi, whatever it is. This is dropping 20%. That's not cool. Okay, and let's say you bought it. You bought it. Let's say 5.5 years ago. 5.5 years ago, and currently, look at that. Currently, you know what I mean there. Currently, it is worth $8,200. That's Kelley Blue Book value right there, $8,200. And you're really considering selling it. Okay, maybe we're in September. You want to sell it by January in a couple of years. So you want to know how much it will be worth in 2 years and 3 months. Now, you know the example I said of September, you want to sell it in January. I would kind of hope it's a Jeep or a pickup truck. Those are the kind of things you sell in the wintertime. That's when there's more demand for them, where Jeeps actually have a lot of demand in the summer too. If it's a soft top, you can take the top off. Convertibles, you don't want to sell them in the winter. You're not going to get crap for that convertible in the winter. Nobody drives around convertibles in the winter. They want them in the summertime. Minivans there, yeah. The summer times are big time for minivans too, because you get the trips going on and stuff during the summer. Pardon that interruption there. There's a announcement going on. So let's take a peek at this guy here anyway. And I look at some stuff disappearing again. So let's bring it back. So we have a car. It depreciates 20% a year. You bought it 5.5 years ago. It's currently worth $8,200. How much will it be worth in 2 years and 3 months? So the value, I like to use a V for the value of it. The value of the car anytime T is $8,200 times. Remember, 20% depreciation means it still retained 80% of its value. So 0.80 is my multiplier and T is my years. So if I want to find out in 2 years and 3 months, well, 3 months is a quarter of a year. That's 2.25. And 2.25 is the same as 9/4. So my value is 8,200 times 0.80 to the 9/4. And we'll jump over to our calculator here, which is not open, but I had opened it earlier. At any rate, I already have this written down. You'll have to trust me on this one. It comes out to $4,963. Okay, and what if you're curious? Well, I forget how much I paid for this car. Well, I bought it 5.5 years ago. So 5.5 years ago. So now we're looking at the value. If we get common denominators here, 5.5 is going to be 5.5 years ago. We're looking at 11 halves, right? And that's negative because it's time ago. So 8,200 times 0.80 to the negative 11 halves. Now this one I do not have written down. So let's jump over to our trusty TI-84. 8,200 times 0.8 raised to the negative 11/2. And we get almost $28,000 here. So that was a pretty nice car there, I hope, for that money. So we're looking at, remember, money, we have to round appropriately, $27,978.15, the sticker price on that car, 5.5 years ago. I believe it was originally listed for $27,999. So you really stuck to that guy and told him, you know what? I'm not paying that much. I want $20.85 off that price. So you get a steal on that one. You got an absolute steal. All right, so that's our rational exponents, and they're fun to play with, and you can do a lot of stuff. We talked about interest and stuff like that earlier. And you can also solve the basic algebraic problems. 2 to the x equals 1/8. Well, 1/8 you have to recognize is the same thing as 1/2 cubed. And that's going to be the same thing as 2 to the negative 3. So we got a property there. X equals -3 is our answer. And then, of course, they can get a little more interesting if I change it to 9 to the x plus 1 equals, okay, now we're talking rational exponents. Square root of 27. Well, again, it's always nice if I can get the bases the same. 27 is really 3 times 3 times 3, or 3 cubed. And 9 is really 3 squared. So 9 to the x plus 1 equals the square root of 3 cubed. The square root right there. Square root. Square root. Okay? So power to power we multiply. So be careful. That's 2x plus 2 equals 3 to the 3 halves. And now we know that our exponents have to be equal. 2x plus 2 must equal 3 halves, which means 2x equals negative 1/2, which means x equals negative 1/4. Final answer there. All right, so these problems can be a little tricky, but bottom line, man, you just work it through. You get your common bases right here. The 3's are common. Here, the 2's are common now that we changed the 8 into 2 cubed. Get your common bases and work for it, man. You should be all right at that point. So we're going to try one last example here. Talking about growth rate, and we'll say a house is bought. The house was bought at $100,000. $100,000. 5 years ago, house was bought $100,000 5 years ago. Today, it's sold for $135,000. So clearly we had a nice increase there. And you can see that we increased by $35,000. Okay, so we had a nice little increase there as well. So the $35,000, $35,000 divided by $100,000, right, showed a 35% increase there. Right, we had a 35% increase over those 5 years. Okay, 35% increase over 5 years. So logic would say, well, 35 divided by 5, so that's a 7% increase per year. And that's really the question. Is that true? Is that a 7% increase per year? And we're going to answer that question in a minute right here. So we have a house that has a value of $135,000. And the initial value, remember, was $100,000. And we don't know what the rate was. Okay, there's some rate in here. We don't know what it was. But it took 5 years for that to happen. Okay? And really, remember, this is our multiplier. Okay, this is the percentage of the house percentage that was either increased or decreased. It's added on to the 100% that was already there. So let's go through and do this math here real quick. This becomes 1.35 equals r to the 5th. And now r equals the 5th root of 1.35. So 1.35 raised to the 1/5 power gives us 1.061. 1.061. I believe there's an 8 in there also. Well, that means that's 106%. 106.18%, which is a 6.18% increase or growth rate. So the actual rate of growth is 6.18%, not the 7% that logic would kind of tell us. And what you have to realize here is that when that house grows by 6.18%, it's now up to $106,000 instead of $100,000. And if you take 6% of $106,000, that's more than 6% of $100,000. Okay, so by taking the same percentage of a larger amount, you're actually getting more money. So it makes it seem like your increase per year is larger than it actually is. And we'll be talking about that more and more as the year goes on. I love this financial aspect of exponents and logarithms. And there's so many things you can do with them. But that is where we will conclude today's lesson, 5.2, Growth and Decay. Have a nice one.